Welcome to The Explainer. Today, we're diving into two SQL operators that create so much confusion: cross-apply and inner join. If you've ever stared at your screen wondering why on earth we need both of them, you are definitely in the right place.
So let's get right to it. Are these two things just different names for the same operator? I mean, really. And what makes this so tricky is that sometimes the answer is, yeah, kinda.
I mean, look at this. You take a super simple case, right? Joining people to their company. You run it with cross-apply, you run it with inner join, and you get the exact same results. Even the execution plans behind the scenes are identical. This is the moment where everyone thinks, okay, they're interchangeable. But, and this is a really big but, they are not.
So, at first glance, they really do look like unassuming twins. For these simple, everyday queries, they behave identically. You can't tell them apart. But now, let's throw a real challenge at them. A problem that will reveal their very, very different personalities. Okay, here is our mission, and I'm sure you've gotten a request just like this one. Our goal is to get the last two orders for each customer. That little phrase, "for each," is the key. This is a classic top-end per group problem, and it's where everything is about to get very interesting.
We're going to use two tables to do this. First up, our master table. It's super simple, just a list of our customers. We've got customer A, B, and C. Easy enough. And here is our details table. This holds all of the orders, and you can see they're linked back by that customer ID. Now pay attention here. Customer A has 3 orders, and customer B has 2. All right. The stage is set.
So, of course, the first tool we're going to reach for is the one we all know and trust, inner join. But as you're about to see, our old, reliable friend is about to fail this test spectacularly.
The most logical first attempt, right? You'd inner join your customer's table to a subquery, and inside that subquery, you just ask for the top 2 orders. On the surface, this feels like it should work perfectly. But there's a huge critical flaw in how SQL actually processes this. And, yep, look at that result. It's completely wrong. What happened? Well, the inner join evaluated that subquery independently. It just went out, grabbed the top 2 orders from the entire table, which both happened to belong to customer A. And customer B, well, they're just gone. This is not what we wanted at all. This failure is exactly what sets the stage for our hero to swoop in. It is time for the cross-apply reveal and the hidden superpower that is tailor-made to solve this exact problem. So check out the cross-apply version of the query. The magic, the secret sauce, it's all right there in the where clause of that subquery. Do you see how it's referencing m.id? That's a column from the outer table, from the table on the left. This ability to connect, to correlate the two sides, that's the whole game.
And there it is, the perfect result. We get the top 2 orders for customer A and the top 2 orders for customer B. It worked because cross-apply ran the subquery once for each customer, one at a time. It did exactly what we intended.
Okay, so we've seen what it does, but let's really dig into the how. What is this magic power that apply has and join just doesn't? It all comes down to one powerful idea: correlation.
The absolute easiest way to think about cross-apply is to picture a for-each loop from programming. It literally goes through the outer table row by agonizing row. It grabs the first row, let's say customer A, and then it runs the entire query on the right, but just for customer A. Then it moves on to the next row, customer B, and does the whole thing all over again. It's pure row-by-row process. And that row-by-row execution, that's what we call correlation. API lets the query on the right side look over and reference columns from the left side. A standard join, on the other hand, can't do that. Its 2 sides must be totally independent, like they don't even know the other one exists.
This power is actually the main reason apply was created in the first place, for using table-valued functions. If you try to pass a column into a function as part of an inner join clause, you get a big fat syntax error. SQL just says no. But swap that inner join for a cross-apply, boom! It works perfectly. It's perfectly legal and does exactly what you'd expect.
But wait,
there's more. Solving top-end problems and calling functions, that's just the beginning. API has a few other superpowers up its sleeve that can seriously clean up your queries. Apply is fantastic for other complex tasks. You can use it to unpivot data, and honestly, it's often a lot cleaner than the actual unpivot operator. It's a lifesaver for simplifying messy, chained calculations, because you can reuse a value immediately. And if you've ever had to shred XML data, Apply is your new best friend.
Let's just take that unpivot superpower for a quick spin. So imagine you have a from date column and a to date column. Instead of some complicated union all statement, you can just use cross apply with a values clause to instantly transform them into a single column of dates. How cool is that? It's just so elegant and easy to read.
All right, we've seen the why, we've seen the how. Let's distill all of this down into a clear, simple guide for when you should reach for this awesome new tool.
Here's your checklist. From now on, whenever you have a top n per group problem, your first thought should be cross-apply. When you need to call a table-valued function and pass in a column parameter, well, it's your only option. And seriously, if your query is turning into a messy web of nested calculations, Apply can almost certainly simplify it for you.
If you remember just one thing, make it this. The very essence, the entire soul of the apply operator is to allow correlation. It's the thing that lets the right side of your query know what's happening on the left side, one single row at a time.
And there you have it. You now have an incredibly powerful tool in your SQL arsenal, one that solves problems that are clumsy or even flat out impossible with a simple join. So the only question left is, what complex query will you simplify first?